Although Parasites and Vectors is a new journal, it comes with an excellent pedigree. It incorporates two previous Biomed Central journals, the Filaria Journal and Canitoplastid Biology and Disease. And we shall, of course, maintain archives of these two journals from our web pages. However, the scope of Parasites and Vectors is much broader than these two. It will encompass all aspects of parasites, parasitic disease, vectors, and intermediate hosts. Biomed Central has an unparalleled expertise in open access and online publication, so that the process of submission right through to publication is very straightforward and intuitive for both authors and for referees. The final manuscripts will be published in a uniform style so that the visual impact will be high and equal to or better than that in the best hard copy journals. So, why do we need a new journal in this field? There are several broadly based, high quality, hard copy journals, as you know. But the niche of Parasites and Vectors is not only defined by its wide scope, but by the fact that it's open access and online. There are many advantages to online and open access, both to authors and readers. As far as authors are concerned, rapid publication is always important, and we plan to publish online immediately on acceptance. There's no preset limit to the length of articles, and we can include large data sets such as may be derived from laboratory and field studies. We can also include unlimited colour, movies, animations and links to other web pages. Reviews will feature in our journal, and some of these may be derived from the plenary lectures at international conferences. For these we can include the slideshows that were originally included in the lectures at those particular conferences. Rapid publication with open access is obviously important to readers as well. In developing countries where research in parasites and vectors is becoming increasingly important, access to hard copy journals in libraries is often restricted. But this isn't only a problem for the developing world, because libraries in developing countries often face repeated budget cuts. So open access is clearly of advantage to everyone. So why would I encourage you to publish in Parasites and Vectors? Well, I've already explained the benefits as I see them of open access and online publishing. But in addition, Parasites and Vectors will have the very highest standards of refereeing, provided by an international editorial board, and of course very many expert colleagues in the scientific community. I am confident that Parasites and Vectors will find a place in the top tier of parasitological journals, and with the inevitable rise in importance of open access publishing, supported, as you know, by grant awarding bodies and governments, I think we shall be at the forefront of this trend. You might ask, how on earth have I found myself in this position? Well, I've always worked in academia, and my most recent post has been Professor of Zoology at Keele University. But for the past 19 years, I have been an editor of the CUP journal, Parasitology. So whatever editorial skills I have learned, I've learned them in a good stable, and I hope to be able to transfer them to my editorial stint in Parasites and Vectors. My research background is in tapeworms. I've focused on two main areas. The first is tapeworm nutrition, and the second is the interaction between tapeworms and their hosts. Tapeworm nutrition is quite interesting because tapeworms don't have a mouth, they don't have a gut, and they don't have an anus. And that means that all movements of materials in and out of the worm must take place across the skin or tegument. And these movements are complex, they're not simple diffusion. They involve transport mechanisms which have occupied my attention for a number of years. I've used the rat tapeworm, Hymenolipis, as a model, and also in more recent years Echinococcus granulosus, which is the causative agent of hydatid disease. The other area that I've taken a particular interest in has been host-parasite interactions, and here the main model that I've used has been a tapeworm called Ligula intestinalis, and I've looked at that stage in the life cycle that lives in fish. Infected fish never reproduce. Their gonads remain undeveloped, and this is because of an interference by the tapeworm in the pituitary glandular axis. The pituitary gland of infected fish is manipulated in some way by the parasite so that the production of gonadotrophins is inhibited. I spent something like 20 odd years trying to find the mechanism whereby this effect is brought about, but unfortunately the mechanism still eludes me.